This is Mrs. Haslauer's video on rotations continued. So we're going to take what we've already learned about our rotations on a coordinate grid on your X and Y and all the rules that we used. Again, those have to be memorized. Those are your responsibility to know. But today we're going to look at rotations without the graph paper, just kind of visualizing it. For some of you, that's going to be very easy. If you're a visual type person, it's going to be no big deal for you. For those of you that aren't so visual, all right, you can do things like twisting your paper to help you out. Make sure you're just turning it in the right direction and things like that. So really, you have the paper in front of you, so twist and turn and try to make sense of it. All right. So just a quick review. A rotation is an image of a figure that is turned about the center point called the point of rotation. Under a rotation, a figure is congruent to its image. Very important. Remember, the only one that didn't keep the shape the same was a dilation. That didn't make congruent shapes, that made similar shapes. Unless otherwise stated, a rotation is in the counterclockwise direction. Very important. All right, so here we go. We're going to rotate the letter P around point O 90 degrees at a time. So for most of us, that's going to be pretty straightforward. Let me get my pen and we will get started. So here's our point of rotation. You need to imagine it as if we're, there's an imaginary line connecting the P to the O, and then we're going to turn it 90 degrees counterclockwise. It's not otherwise stated, so we're going counterclockwise. If it helps you, draw the hands of a clock. We got 12, 3, 6 would be down here, and 9 would be over here. Just faintly on your paper, because then it helps you realize, okay, this would be clockwise, and going to the left would be counterclockwise. So imagine me spinning the P. All right, we're going to go this way about O. So it's going to end up about here on its side. Now you're going to try your best to keep it equidistant from the O, and you're going to try your best to make it approximately the same shape. The shape doesn't get bigger, it doesn't get smaller. Same shape, it's just kind of tipped over. Okay, so there would be 90. Let's go all the way around. If we did 180, this would be swinging down here, so you'd end up with a P that is upside down. Okay, I know mine's a little smaller, but it's not because I'm out of room. And then 270 would be up here. Okay, so this one would be 90. Down here would be 180. And this one would be 270. What I need you to pay really close attention to is notice that the P is not reflected over the O. If the P was reflected, the vertical line would be here. The vertical line of the P would be over here. This is not a reflection, it's a rotation. That's going to be really important when we look at our class work, because you're going to have to identify what I did, if I translated, reflected, or rotated. All right, so let's keep going. What we're going to do, we're going to name the image of point A under a clockwise rotation up. So I'm giving you the degree measurement that I want you to rotate around according to A. So A is what we're rotating around. We're going to go clockwise in the first case. So again, if it helps you, put your numbers of a clock. So really faintly on your paper, that would be 12, 6, 3, and 9. Clockwise means we're traveling in this direction. We're going to the right. Very, very important, guys. Clockwise means this way. Counterclockwise would send us to the left. We don't want to go the wrong way. So in this case, our circle, our 360 degrees, is being broken up into 60-degree increments. So B is at 60, C is another 60, D is another 60, and so on. So if I have A and I'm rotating at 60 degrees, that's what we're looking at first. A will now be at point, boom, B. If I were to rotate A 60 degrees clockwise, I would now be at letter B. Now they're asking, well, what if you rotate 360? 360 is how many degrees there are in a circle. So if I'm starting at A, I'm going to rotate 360 degrees around the circle and end up right back at A. If I'm at A and I'm traveling 180, you might say to yourself, well, there's not a 180 on the circle. Well, 60 degrees would bring me to B. Another 60 would bring me to 120. Another 60, so 120 plus 60 would bring me at 180, or where letter D is. 180 is half a circle. It's half of 360. 300, well, we already know that 180 is down here at D. If you add 60 to 180, because we're traveling another 60 degrees, we're up to 240. So we're almost there, but not quite. 240 plus 60 would bring me up to 300. And last but not least, 240, well, we've already got that marked. If I start at A and I go 180, which is halfway around the circle, plus another 60 would bring me right to 240, which would be E. So those are my rotations going clockwise. Now we're going to look at the exact same circle going counterclockwise or anti-clockwise. They're the same thing. It just means going the opposite way of a standard clock. If it's helpful, faintly on your paper, draw the 4 parts of a clock. Keep track that you're going the correct way. It's very easy to go the wrong way. Counterclockwise, we're headed left around our circle. Again, it's broken up in our 60s, 60-degree increments. We're still starting at A. So here we go. If we're going 60 degrees counterclockwise, we're not going to be at B anymore. We're going to be at F. 360, let's see, going counterclockwise. F, E, D, C, B, A. Right back to A. 180, again, hopefully you remember 180 is halfway around the circle. So if I go halfway around the circle, I'm going to end up at letter D. 300. If you can't do the math in your head, you're going to write it out. Again, 60-degree increments. So F would be 60. E would be the same as traveling 120. D is 180. C would be 240. And B would be 300. Where did I get the 300? I took 240, added it to another 60-degree rotation, and I ended up traveling a total of 300 degrees. So A would now be at letter B. And last but not least is 240, 60, 120, 180, 240. I would end up at C. Now this is a great question. What degree measures are equivalent? Well, let's check it out. This top one we went clockwise and the bottom one we went counterclockwise. So we keep talking about how important it is to make sure we're going in the right direction. But hopefully when you look this over, you're noticing that there are some similarities here. The 180 is the same. We started at A and ended up in D in both cases. And 360 is the same. So that's very important for you to understand. All right, traveling 360 degrees is going to bring you right back to where you started. And traveling 180 around a circle is going to get you to the same point also because it's the middle of it or the center. So those 2 degrees, it doesn't matter which way you're traveling, but for everything else it does. We also know that even if we're not going at 60-degree increments, right, when we were using the grid paper and going 90, 180, 270, and 360, the same thing was true. 360 would bring you back to the original, and 180 had the same rule whether you were traveling clockwise or counterclockwise about the origin. All right, so let's flip the page and see if we can figure this out. Again, it's all visual. There's no grid paper for these, so you have to do your best. You're more than welcome to twist your page. I can't do that up here, but you can do that on your note sheet. So what I'm asking is how many degrees is each rotation? It's very important for you to realize this is a rotation. All right, it's not a reflection. I didn't flip this smiley face to get to this smiley face. What did I do? Well, I can either go clockwise or I can go counterclockwise and get the same image. So what I'm going to do is faintly on my paper, I'm going to draw my clock so I don't make an oops. First, let's look at it clockwise. If I started here and traveled clockwise or turned my smiley face down here, how many degrees did I travel clockwise? Hopefully everybody can tell me that's a 90-degree rotation. Okay, it's not down here. All right, it's not the 180, and it's definitely not 270 over here. It only traveled 90 degrees. Well, how about if I go counterclockwise? Counterclockwise means the opposite direction, towards the 9. Over here would be 90, down here would be 180, and up here would be 270. All right, we should remember this from yesterday, that those two values are equivalent. That's why you only needed to memorize the 3 rules, because they can be used either way, but you got to keep track of which two values are equivalent. All right, so let's go to the hearts. Clockwise, 12, 3, 6, 9. If I travel clockwise, 90 would have the heart on its side, looking kind of like that, but it's down here. That's definitely 180. And then if I go counterclockwise, same thing. Here would be the heart if it was 90, counterclockwise. It's not. It's down there. It's 180. 180, just like we talked about in the last slide, are the same. No matter which way you go, you end up with the same shape. This one here, we got 12, 3, 6, and 9. If I'm traveling clockwise, well, let's see. If I went 90 degrees, I would end up with a circle that was kind of facing down. The moon would be down here, all right? And the arch would be up there, so it's not 90. 180 would kind of look like that. So there's your 90. 180. But it's kind of facing up. The curved part is facing up, so that has to be 270. If you turn your page, you'll be able to see it. 270 means turning it 3 times. Twist your page 3 times, and you'll see that this kind of moon shape ends up looking like that. So that's definitely 270 over clockwise. And then counterclockwise means go the opposite direction, and you end up with the moon looking like that if you just travel 90. Draw these pictures. They're very, very helpful. And last but not least, we have the shirt picture. Let's see. We're starting here. We got 12, 3, 6, and 9. If I travel clockwise, I'm headed this way. Try to imagine the shirt being kind of twisted down here. That's only 90 degrees, because 180 would end up with the collar down here and the bottom of the shirt up here. So it's not 180. It's just 90. 90 clockwise, we know, is equivalent to 270 counterclockwise. All right. Now with these shapes, this is called a point reflection because it's a point right on the shape. We've got the corner of F, and you need to pay very close attention to the arrow. The arrow is going to tell you what the original shape was and what the image is. So here's the object, what we're starting with. There's my image. I'm tipping it this way. It wants you to describe the rotation. Again, it's not a reflection. You have to realize that I'm just rotating it over to the left, going this way. So let's see, what can we say about this? We can say that it's very important to talk about where you're rotating. Are you rotating about the origin? Are you rotating about a point? In this case, the black dot, because it's not labeled A, or we don't have any sort of, notation on it. So I'm just going to say that the black dot is the center of rotation. The letter, in this case it's the letter F, was rotated 90 degrees. Do you think it's okay for me just to write 90 degrees? Hopefully not. Hopefully you're saying, well, wait a minute, 90 degrees one way is not the same as 90 degrees the other. In this case, I'm going from 12 to 9, so this is counterclockwise about the center of rotation. All right, it's good to be descriptive. All right, some of us are very kind of lazy when it comes to writing our descriptions, and you wouldn't put enough in there. You got to talk about where it's rotating, which direction it's rotating, and the degrees of rotation. 3 very, very, very important things to talk about. So why don't you pause the video and try these 2 on your own. All right, see what you would write down. Again, pay very close attention to the arrows, and then I'm going to write down the response that I'm hoping you can do on your own. All right, so pause the video and try to write it down. All right, we're going from 9 to 12. That's a clockwise rotation. So in this case, the rotation is 90 degrees clockwise about point A. All right, I don't have to say the black dot in this case because they're labeling it with a variable. Shape is still the same, exact same, congruent. All I did is rotate it. And here's my object, here's my image. I'm going this way, so I'm going from 12 o'clock to 9 o'clock. So this one is a rotation of 180 degrees. Why is it 180? Well, because this is technically starting all the way back at 3. We're going up here would be 90 if you ended up with your shape up here. And then 180 brings it, kind of opposite. Okay, full half circle rotation. Counterclockwise about point B. Quick little multiple choice. I want you to see how closely related they are to each other, so please be careful when you're picking the correct answer. All right, you want to make sure you're picking the most descriptive one. In this case, we're going from 12, 3, all right, so we're going in a clockwise direction. So you definitely want to get rid of the one that's talking about counterclockwise. And it's definitely going to be C. The triangle is rotated 90 degrees clockwise about point A. Notice that A is tempting to pick because it says the same thing. It does not tell you the point of rotation. You want to pick the one that's most descriptive. And then this one here. What is the best description of the rotation? Well, 12, 3, 6, and 9. We're going from 12 to 9. So that's definitely a counterclockwise rotation. Get rid of those clockwise ones. That gets rid of A and C effortlessly. Let's look at B first. The center of rotation is X, and the angle of rotation is 90. Maybe. Let's look down at D. The shape is rotated 90 degrees counterclockwise about X. There we go right there. All right, that's definitely what we want. And make sure that you're very careful when you pick the appropriate one. This one does not mention which way to rotate. Remember that 90 degrees clockwise is not the same as 90 degrees counterclockwise. So we're going to work in class on identifying these rotations, and then we're going to be asked to map, identifying the difference between rotations, dilations, translations. All right, so if you have any questions, please let me know.